All right. So we are going to just practice like we've always been, looking at finding particular probabilities. We've done it for just looking at a sample value, so just an X value. We looked at looking at a sample mean. Now we're looking at it for looking at a sample proportion. So not much really has changed here. The one thing that has changed is that I have to check to make sure that my distribution, that the distribution of my sample means is normal. So that's the one thing that is the only change here. I have to look for that. According to Harris poll, chocolate is the favorite ice cream flavor for 27% of Americans, meaning that if I look at my sample proportion, it's 0.27. If a sample of 100 Americans is taken, what is the probability that the sample proportion of those who prefer chocolate is greater than 0.3? Okay, so we're looking at a sample size of 100, and my distribution of p hats is what I'm going to be analyzing. So first I have to check my assumptions, which means I'm really just checking to see, like I said right here, the one thing that I have that changes from all my other kind of distributions is I just have to make sure that my distribution of p hats is normal. So that means I have to find n times p. So n is 100 and p is 0.27, which is going to give me 27, which is greater than 100, or 10, sorry. I have to find p times 1, or n times 1 minus p, which is going to be 100 because that's my n. And 1 minus p is going to leave me with 0.3. So that's going to give me 63, which is also greater than 10. So that tells me that p hat is normally distributed. So I actually can go back and find a probability. Sorry. So we always have to check for that to make sure before we even attempt to find the probability, make sure that we even have a normal distribution. Because if we don't, everything we find out is really just gibberish at that point. Because everything with means and standard deviations really only apply to normal distributions. Okay. So remember, we said n is 100. We said p is going to be 0.27. So if we look at our distribution, what is it we're actually looking for here? We're looking for the probability that if I have a randomly collected group of 100 people, that their sample proportion is going to be greater than 0.3. So we're looking at this area right here. Before I can even find that proportion, I need to have the mean and standard deviation of a sample of a distribution of p hat. So I need to find mu sub p hat, not x bar, which is the same as my population proportion. So that means the mean of this distribution, so the mean of my proportions is going to be centered around 0.27. The standard deviation is the square root of p times 1 minus p divided by n. So that is going to be 0.27. And 1 minus p, we just found that was 0.63. So I'll just put that in there, divided by my sample size, which is 100. And this is going to give me 0.044396 approximately. Okay, so let's plug this all into the TI-84. Okay, so get this so I can fit in here. Most of this information is going to be in here because I already did this once. Sorry, we're going to second vars because that gives me my distributions, and I want number 2. So let me clear everything here a little bit. So remember, this area is what we're looking at. So we have to do the lower bound of the area. So in the lower end, it's bound by 0.3. At the upper end, this is technically going to infinity. So we just do 1 followed by several zeros, just kind of going out towards infinity. The mean of the distribution is 0.27. The standard deviation is 0.044396. We hit paste. And what we're getting is that the probability that my proportion is going to be 0.3 or sorry, over 0.3 is 0.2496, or approximately we say 0.25. So about 25% of samples of 100 Americans will have 30, because that's what we're looking at, is that proportion is 30 or more people who like a chocolate ice cream. This is something that we pretty much are basically saying we expect that if we were going to go out and get a bunch of ice cream from people, there's a 25% chance that 30 or more of our people are going to like chocolate ice cream. So it tells me that chocolate ice cream is, like if I was getting to have a party, chocolate ice cream is definitely a flavor I want to have available. And I probably want to have a lot of chocolate ice cream because there's a high probability that, like I said, 30% or more of my people that I come to this party are going to like chocolate ice cream. Right. So going back, so for our next problem, this is going back to the idea of what is unusual or not, because when we do hypothesis testing, one of the things we're looking for is what's unusual. So approximately 60% of eligible voters voted in a recent US election. So that means that my population proportion, is 0.6. If a sample, so my sample size of 88 eligible voters was polled, would it be unusual if less than half of them voted? This is my distribution. Like I said, we expect it's actually going to be 60% of people are going to vote, but we're going to know, isn't unusual if only 50% or less vote. So we're looking at this area right here. So before I even do anything, I have to check my assumptions. I have to make sure that this is normal. So I need to do my n times p. So my 88 times 0.6. Which is going to be 52.8, which is definitely over 10. Then my n 1 minus p. So that is going to be 88 times, and 1 minus 0.6 is going to be 0.4. So 88 times 0.4, that is going to be 35.2, which is also greater than 10. So yes, this is normal. So we need to have the mean and the standard deviation of my distribution. So the mean is going to be the same as the sample proportion, or sorry, as the population proportion, so 60. The standard deviation, we'll find that over here. That's going to be the square root of the population proportion, so the 60 times 1 minus, so 0.4, divided by the sample size of 88. So square root of 0.5 times 0.4 divided by 88 is going to give me 0.05. We'll go 2, 2, 2, 3. So the further you round that out, the better your approximations are going to be later. All right, so let's get rid of this part here. So make a little note up here. What we're looking for is the really it's what is the probability that my sample proportion would actually be less than half. Yep. Less than half, so less than 0.5. Okay, so we go to second bars again, go to number 2. So if I'm looking at it like this, less than, we saw this already, this means that this area is bound from negative infinity up to 0.5. So my lower end is going to be -1 followed by several zeros. Let's try that one more time. -1 followed by several zeros. My upper boundary of that area is going to stop at 0.5. The mean of this distribution is 0.6. The standard deviation is, there's a zero missing here. That standard deviation was a little too high. 0.05223. This is 0.028 approximately. So there is a 2.8% chance that less than 50% of your voters out of a group of 88. So if we had like a little a city election or something like that, 88 registered voters like in a small town, and they had to come in and vote. If we have less than 50% of them come through, there is a 2.8% chance of happening. That is definitely less than 5%. So this would be unusual. So it's kind of a hint that there's something going on in this area. That's kind of skewing. There's something going on where people are not coming in and voting, is what that's telling me. Because it's unusual that only 50% of my voters would be coming in. So that kind of tells me that there's something probably a little weird going on, and I have to look into it. Like, why are people not voting? The whole point of looking for what's unusual is that's a hint that there's something wrong, and it's something we need to investigate. So one more example here. So I'll write down the data on the side here. Um, a general social survey reported that 56% of Americans saw a doctor for an illness during the past year. The population proportion, 0.56. A sample of 65 adults is drawn, and we want to know, A, what is the probability that more than 60% of them saw the doctor? So if I have my sample of 65 people, what is the probability my p hat is going to be greater than 0.6? Or like I said, the probability that more than 60% saw the doctor? B is asking us, would it be unusual if more than 70% of them saw the doctor? So it would be unusual if I looked for my p hat and my sample proportion, but it was greater than 70. Okay, so just need to check if the distribution of p hats is normal. So I need to do n times p, and I have to do n times 1 minus p and see what I get. So that is 65 times 0.56, which is going to be 36.4. So that is greater than 10. So that's okay. This is going to be 65 times 1 minus 0.656. 1 minus 0.56. And that is going to be 28.6, which is also greater than 10. So next part we need is we need the mean of this distribution. So the mean of my population, sorry, the mean of my sample proportions matches the population proportion, so that's 0.65. And the standard deviation would be 0. Sorry, not 6556, 0.56 times 1 minus 0.56 divided by 55. And we get a 0.06. Let's just round a little further. 616. I should do further, but that'll be good for now. So remember what we're looking for is we're looking for greater than. So the A is a population that, so the distribution is centered here. We're looking at 0.6 or greater. And then for B, we're looking at 0.7 or greater. So go to second bars, go to number 2. We're going to see for A, we're bound at 0.6 and then go to infinity. So 1 by as many zeros as we possibly can. The mean is going to be 0.56. The standard deviation is 0.0616. So we got a probability of 0.258. So the probability that 60% of my patients are going to or 60% of my population or my sample, so say it again. So we got sample 65. The probability that 60% of them are going to the doctor is about 26%. Okay, so we'll do that again. This time the only thing it changes is now for B, we're just bound at 0.7, but everything else is the same. And here, the probability drops significantly. We got a probability of 0.0162. So here we're saying that out of 65 people, if I have a group of 65 people, if I have about 70% of them going to the doctor, the probability of that happening is 1.2. Like I said, this is less than 5%, so this would be unusual. So if I find a population of people and about 70% of them are regularly going to the doctor, that tells me there's something unusual going on with that population I need to look at. There may be some reasons they're feeling sick or something like that, but there's a bigger reason why they're going to the doctor and they're a group of people I need to investigate.